Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. Okay, let's look at the first example in quiz 3. So consider a signal given by the equation ft equal to modulus sine t with period or fundamental period equal to pi. So you need to determine whether the function is odd, even, harmonic, skew, or combination of the functions. So in order to solve this, you need to know how this sine t signal looks like, or you can also try different t values. Then you can estimate what types of signal is this. So in this discussion, I would like to use sketching as part of the solution. So basically, you should know how the sinusoid signal looks like. So for sine t, it usually looks like this. Okay, so but in this case we have the modulus. Okay, we have the modulus sine t. So when it has modulus, meaning that all the negative amplitude will be positive. So all this negative amplitude will be positive. And this one as well. Okay, so the signal looks like this. Okay, so from here you can determine whether it's odd, even, harmonic, skew, or else. Okay, so from here obviously you can notice that the signal is symmetry. Okay, it's a mirror image, and so that the signal is basically an even signal or even function. And you can see also the t, the fundamental t, repeating again and again. Okay, so this is basically harmonic signal as well. So this function is an even function because it is symmetry at y-axis, and it also harmonic signal, as you can see the repetition of the fundamental signal by the same fundamental period. Okay, so basically when you answer a question, please also provide some statement or justification to your answer. Okay, in the second question, you need to use Fourier coefficients table to express the trigonometric Fourier series of ft for up to third harmonics. When you notice third harmonic, so your n should vary from positive and negative 1, positive and negative 2, and positive and negative 3. Also when n equal to 0, so representing your c0. So as usual, you need to refer to the coefficients table. So look at the closest shape of signal to the signal you have. This is from question 1. So from question 1, you have this shape. So when you compare to the Fourier coefficients table, you may notice that full wave rectified signal having more or less the same shape as the signal you have. So from here you can determine the C0, Cn, and also the final column, the last column, represent the remark. So don't forget to check the basic equation of exponential function. So from the coefficients table, you will create or you will develop Fourier series equation in exponential form. But the question asks you to come up with trigonometric form, meaning that you need to develop the exponential form first from the table, and then you can convert the exponential form into trigonometric form. Okay, so by comparing the signal in the table and the one you have, so you may notice that x0 is equal to 1, and your omega naught is equal to 2 pi over t, in which t0 in this case equal to pi. So in this case, your omega naught is 2 radian per second. Okay, next, remember the basic equation of exponential Fourier series. So it is C0 plus the summation of Cn, the coefficients e, j, and omega t. So in this case, your omega equal to 2 radian per second, and n varies from 1 to 3. And then you need to look at your C0 and Cn equation. So in this case, C0 equal to 2x0 over pi, in which x0 equal to 1. And then replace this x0 as well, divided by pi 4n squared minus 1. Okay, so in this case, your omega is 2. Okay, so replace x0, omega, and omega values. So you get the general equation of Fourier series. Then you need to consider the coefficients. So this is your Cn. So you need to vary the n up to third harmonics. So this is your Cn equation. And then varies when n equal to 1. So when n equal to 1, when n equal to 1, so you got negative 2 over 3 pi. When you have n equal to negative 1, so when you have negative 1 squared, so you get the same answer. So this is the Cn for both positive 1 and negative 1. Next, when Cn equal to 2, okay, so replace n equal to 2, so you get negative 2 divided by 15 pi. So when you replace n equal to minus 2, so minus 2 squared becomes positive. So again, you have negative 2 over 15 pi. So third harmonics, C, when n equal to positive 3 and negative 3, so replace n equal to positive 3 and negative 3, so you get the same Cn values. Okay, once you have the Cn values, then you need to replace your Cn into the general equation and then vary the n as well. Okay, so this is from the earlier derivation. Okay, you have all your Cn values. Now you need to replace all Cn values and also derive this exponential function by varying the n as well. Okay, so in this case, this is your C0, so this is your C1, and this is your C minus 1. Okay, C minus 1, E, replace the n equal to minus 1, positive 1, 2, negative 2, 3, and negative 3. Okay, so expand the equation. So this is for C n equal to 2. This is when C n equal to minus 2. This one is C n equal to 3 and C equal to n minus 3. Okay, so to convert the equation, now you already have the equation. Okay, from the coefficients table, you can develop exponential Fourier series equation. So to answer the question and to come up with trigonometric equation, you need to convert your exponential form into trigonometric form by using Euler's theorem. Okay, remember Euler's theorem, when you have cos theta t, for example, it is equal to e j theta t plus e minus j theta t divided by 2. But when you have a sine function, sine theta t equal to e j theta t minus e minus j theta t divided by 2j. Okay, this is the this is derived from Euler's theorem. So now when you have the exponential form, you can group the one that have the same coefficients and the same frequency values, but the frequency varies for positive and negative frequency. So group them, okay, based on the frequency values and also the coefficient values. And then from here, you can compare with Euler's theorem. So this is basically in cosine shape. So to get this into cosine, it must be divided by 2. Okay, so in this case, you need to divide this by 2. So you need to multiply here by 2. Same goes to the omega equal to 4 divided by 2. Here multiply with 2. And also the third harmonics divided by 2, multiply with 2. Okay, so now finalize your equation. So you have your Vt equal to 2 over pi. This is 4 over 3 pi cos 2t minus the second harmonics and minus the third harmonics. Okay, you can also convert this negative into positive by having positive pi phase shift. Okay. Now let's look at the second question. So signal xt is applied into an RC circuit as in figure, I suppose it is supposed to be figure 2, Q2. Okay, this is the xt. The signal is xt is given by this equation. So you need to determine the trigonometric cosine Fourier series of voltage yt, meaning that the output signal for up to third harmonics. Look at the equation. So here you have n, so n varies up to third harmonic. So you have 1, 2, 3. So for trigonometric equation, you don't have to consider the negative values. So you just need to consider the positive values. Why? If you still remember that the trigonometric equation will produce single-sided spectrum. Okay, that's why you just need to consider n positive values. Alright, so in this case, look at the remark. So this equation valid for n equal to 1 and n odd. Okay, so you don't have to consider n even number. So in this case, the n varies from 1 and 3. Alright, so second question, you need to plot the magnitude spectrum. So magnitude meaning that you need to have both the amplitude and also the phase. So that's why the marks is 4 marks. So you need to produce both the amplitude and phase spectrum. And lastly, you need to determine the average power of the signal yt, the output signal. Okay, so next you need to determine, okay, the first question, you need to determine the trigonometric cosine Fourier series of the output signal yt for up to third harmonics. Okay, as mentioned earlier, so you just need to consider n equal to 1 and n equal to 3 in this case because the n only valid for odd numbers. Okay, so the xt, look at the source, xt is equal to 0.5 plus, okay, so when you replace n equal to 1, so this is represented by x1. So when you place n equal to 3, so this is, the source is x3. So now this is the equation when you have replaced the n equal to 1 and n equal to 3, representing the first and the third harmonics. Okay, so to determine yt, the output signal, so you need to consider the component, the passive component involved in the circuit or included in the circuit. So you need to redraw or define the equivalent circuit. So by replacing the component with Fourier series equivalent circuit. So in this case, R will remain as R and C will become XC, in which XC equal to 1 over J n omega naught C. So n is the harmonics number, so omega naught is the fundamental frequency, angular frequency in radian per second. Okay, so in order to get yt, so you need to use voltage divider. Okay, so voltage divider, yt equal to xt multiplied with xc divided by r plus xc. So the source multiplied with xc, divided by r plus xc. So don't forget xc equal to 1 over j and omega naught c. So what is your omega naught? So from the equation, you will see that this is the omega naught. So omega naught in this case equal to pi. Okay, so you can replace your omega naught equal to pi. And this one as well. And then your C is equal to 0.5 farad. Okay, what else? And then, okay, so N will vary either 1 or 3. Okay, so now expand the equation by considering the N. Okay, so the first one, when you have xt multiply, so yt equal to xt multiply with your impedance, okay, the total impedance in this case. So 1 over g 0.5 is c, this is omega naught, and this is your n. So here is x naught when n equal to 0. So when n equal to 0, so in this case 0.5 multiply, this is when x 0, 0.5 multiply with this equation when n equal to 0. Okay, next, when n equal to 1, so this is when n equal to 1, so x1, now it becomes x1 multiply with this equation when n equal to 1. Okay, move on to the next harmonics when n equal to 3. Okay, so now it is x3 multiply with the component when n is now 3. So now you need to solve the rectangular function, so in which you need to convert this rectangular function into polar form. Okay, so then finalize your equation. So x1 in this case equal to this. This is your x1, and then x3 equal to this equation. Okay, so you need to complete your derivation and calculation. So at the end you get your yt. So second question, you need to plot the magnitude spectrum for both the amplitude and also phase. So you already have the amplitude here when n equal to 0, when n equal to 1, when n equal to 3. So this is your omega 1 and this is your omega 3. So plot the magnitude spectrum. So this is when n equal to 0, n equal to omega equal to pi, and omega equal to 3 pi. So next is the spectrum. So the spectrum, the phase spectrum. So for when the frequency equal to pi, so the phase is negative 147.52. When frequency equal to 3 pi, so the phase equal to negative 168.2. Don't forget to label all values, and don't forget the x-axis and unit as well. If you know this one, if it is volt, then you need to put volt. Okay, last question, determine the average power of signal yt. So how to calculate the average power? If you still remember, the Passavant's theorem stated that the average power is basically the sum of the average power in its harmonic components. So let's recall the equation. If you have exponential spectrum or a frequency spectrum, so you can calculate the P average by having the magnitude of each component or its harmonic. So starting from your C0 squared plus 2 times of your Cn squared. Okay, so y multiply with 2. If you remember the exponential spectrum, you have both double-sided. Okay, so example at pi and negative pi, both having the same amplitude. Therefore, you can just consider C1 or C pi in this case. The magnitude is 1, so that's why you multiply by 2, because you have the same amplitude at negative pi. Or you can also expand your equation manually. For example, this is negative 2 pi and this is 2 pi. The amplitude is 0.5 and 0.5. So your P average in this case will be, so you have your C naught, for example, 1 as well. Okay, so you have the P average equal to C naught squared is 1 squared plus C pi squared, so it's 1 squared again, C minus pi squared, so 1 again, plus C2 pi squared is 0.5 squared plus C minus 2 pi squared is 0.5 squared. So this is equivalent to C naught squared plus, if you see that, you have when n equal to 1, positive pi and negative pi, so it's 2 times 1 squared plus 2 times 0.5 squared. So it's the same thing. Okay, so this is to simplify the equation. But when you have single-sided spectrum or trigonometric equation, so you can calculate the P average by using this equation, 1 over 2 of your Cn squared. Okay, so in this particular question, you have the single-sided spectrum, so you can consider this equation. Okay, so you need to total the magnitude of each harmonics of this single-sided spectrum. So you have 1 over 2 multiply with the summation of your Cn squared. So you have your Cn, C naught squared is 0.5 squared. This is C naught squared plus your C pi is 1 C pi squared plus C 3 pi squared. Okay, so you get the power average for the output signal Yt equal to 0.309 watt. Okay, lastly, please scan this code for attendance, and later I'll upload more example on Fourier series with solution, so you need to try the example and derive the equations yourself. So to summarize, so in Fourier series, obviously you'll notice either it is in trigonometric form or it is in exponential form. Okay, so the basic equation for Fourier series is using the integration, but to simplify, we use the table, the Fourier series coefficients table, to derive the Fourier series of a given signal. So remember, from the table you will have the C naught, and then you have the Cn equation, and you have the remarks. So don't forget the general equation. For example, xt equal to C naught plus the summation of Cn ej and omega naught t. And from the table, when you compare the given signal, so you will get the exponential Fourier series. So in order to get trigonometric form, so you need to convert this exponential into trigonometric form by using the Euler's theorem. Okay, and lastly, in the application, you can calculate the P average by using the Parseval's theorem. And you can apply Fourier series in circuit analysis. Okay, meanwhile in trigonometric form, so you need to be able to sketch the signal or the waveform in time domain. Okay, so waveform is basically the signal in t domain. So you need to be able to manipulate the equation if you have sine omega t. So how to convert it into cos? So it's equal to cos omega t with phase shift of pi over 2. And if you have negative cos omega t, for example, so this is equal to positive cos omega t with phase shift of pi. And then when you have also, okay, you need to apply the concept you have learned in the first chapter, signal operation as well sometimes. So if you have complex equation, so sometimes you may need to use a trigonometric identity to solve the equation. Okay, trigonometric identity table will be provided during test or exam. So for example, if you have cos squared omega t, and this can be expanded by using identity. For example, cos 2 theta equal to 1 over 2 dot dot dot. Okay, so you may see you can simplify the equation by using trigonometric identity. Okay, so hope this helps. So enjoy and good luck.